Yes.
Yes, I got it. Okay. So we are now on live stream.
Yes,
Woohoo.
we are. There we go. And Richard Grace is first on base. There we go.
Hey, Richard. Glad to have you aboard.
Let's see. There we go. All done. So how was your weekend?
The weekend was good. Busy, did a lot of writing. Still working on the draft of Star Mentor. And that's just about ready to send to publishers. Another few days work on that. I had some friends who actually said, I'll read it. And then they did, which was very nice of them. And I'm looking forward to that. We'll see if I get it to them now. Who knows? Maybe they'll have it ready for first quarter 22. That would be spectacular. So
I'm always stunned at how much you are able to write. That's a gift, Daniel.
Well, part of it, my friend, is that if it's something you've literally been teaching others to do for 40 years, at this point, I used to joke with people that you could wake me up in the middle of the night, I could get up in my PJs, put a whiteboard and a marker in front of my hand, and I could teach physics and astronomy from a dead sleep and just give me a topic and I could go.
Cool.
And that's
Maybe we should
only
do that for some of these shows.
Hi, kids. Yeah, it's only half a joke because literally, I think the best interview I ever had, the best job interview I ever had, was at Centennial High School in Corona, California. And I was applying for a job and they said, yeah, sure, come on out. They gave me the directions and I walked back to the lounge where the science staff hung out. And so we chatted for about 15 minutes. What have you done? And what do you think about this or that? And so the boss looks at me and he grins and he says, okay, now it's time to see if this is all BS or not. I said, well, what do you mean? He says, well, and he looks at his watch and he says, you're scheduled to give a guest lecture in our honors physics class in 5 minutes. And I go, oh, okay. What am I giving a lecture on? He says, your pick. Do you want a book? I said, I don't need no book. He says, oh, good. What do you need? And I said, well, I need some ping pong balls and some kite string and some tape. And if you don't have ping pong balls, anything I can use as a weight. He said, well, corks do? I said, sure. So I walked in and he sat down in the back of the room. A couple of the other teachers sat down. I said, hi, I'm your guest instructor today. And I'm here to teach you about parabolic motion. And I said, what would you say if I asked everybody to raise their hand who could solve a parabolic intercept equation in 3 dimensions in their head in less than a second and a half. I said, who's got the prerequisite? Who's ready to do that? They're all looking at me like I'm nuts. I pointed at them like, liars, I know you can do this. You're lying to me. And so I pointed to the biggest, dumbest kid in the football jersey in the back of the room. I'm like, you, what's your name? Joshua. I'm like, Joshua, you can do this problem, right? No, liar, I'm not. And I took out a Snickers bar. I said, do you see this, Joshua? He said, yes. I said, good catch. And I tossed it to him. And I knew he's a football kid he could catch. Holds up his hand and he grabs a freeze. And then we hung corks from the ceiling by string.
New NASA
showed the parabolic path across the classroom.
are not only younger than
Math.
previously thought, but also that these rings are actually disappearing at an extremely fast pace. The research found that the rings are draining away toward the planet as a dusty rain of ice particles. Saturn's rings consist mostly of water ice that ranges in size from microscopic dust to large boulders. Ultraviolet light from the sun and plasma clouds coming from tiny meteoroid strikes charge the icy dust, which then becomes bound to Saturn's magnetic field and pulled into the planet by gravity. This material rains into the planet and begins to disintegrate, allowing it to react chemically with the electrically charged part of Saturn's upper atmosphere, the ionosphere. The ions glow in an infrared light as part of this process if the rain is light, but the emissions dim if the rain is heavy. This was observed using instruments attached to the Keck telescope in Hawaii. The rate of disappearance in this ring rain study has allowed scientists to infer that Saturn's rings formed less than 100 million years ago. This means Saturn wasn't born this way, as the planet is known to be over 4 billion years old. And when the ring rain data is combined with observations made by the Voyager 1 and 2 missions, scientists from NASA Goddard are able to estimate that the rings will be gone in 300 million years. So if this ring doesn't go away, Saturn will be ringless another day.
I love it.
Saturn will be ringless on another day.
Spectacular. I was going to say, you got to put my brother on.
Is that your brother, Dan?
No, none of my brothers look like me. So a fact for which they are all thankful.
Right. Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance. And if I can just get my camera lined up, maybe you can see. There we go.
This is how we know it's live TV.
It's live TV. That's right. You see the camera moving. So hope you guys had a great weekend. It was restful for me. And actually, we had a couple of nice, clear nights, even though we had hurricane-like storms kind of sweeping close to us and everything, but the air was clean and the skies were clear, and got a nice view of Saturn and Jupiter last night. That was nice. So enjoyed that. Today's subject is sketching Saturn.
Yes.
And a lot of people in this day and age of astrophotography and a bunch of really cool astrophotographs being made, especially the planetary stuff.
Stunning.
Daniel has been keen to teach us how to draw at the eyepiece and what can be learned by drawing. Okay, it's a very active process, I think, and it's something obviously before photography was invented, to record data, the discoveries and all the rest of it. It had to be done through writing down text and also sharing the visual experience, and in no other way except for drawing it. So, Galileo with drawing the ears on Saturn, and then as we go up to progress into Cassini, who had a much more superior telescope, but Daniel has over the years developed methods for making highly accurate drawings, and so he's going to share those with us today. And what is the benefit here, do you think, Daniel, of drawing Saturn versus photographing Saturn?
Well, I think there's a number of advantages, Scott. I had an evening one time this summer with a good friend who's an experienced astrophotographer. He was using an Explorer triplet and a beautiful instrument. Mm-hmm. And he had,
Thank you.
I think, an 80 or 100 millimeter finder scope and a tripod and everything. And he came out, "Oh, can I come out to your house? I want to take some pictures." Thor's helmet was on his list that night. And I said, "Sure, come on out." And he came out and he brought his equipment. It was very beautiful. And he had a box of electronics, and he had cameras for the guide scope. He had a camera at prime focus for the imaging, and he had his laptop, and he had everything set up, and he put a blanket down on the ground, and he spent about 3.5 hours that night looking at the monitor on his laptop.
Okay.
And he didn't even have an eyepiece for his telescope with him at all. He looked through mine a number of times. Wow, that's really impressive. But he would go back, and he was taking short exposures, which he sent me a copy a few days later, and he said, oh yeah, just 5 or 6 hours at the computer processing, and here we go, and look at how beautiful this is. And I couldn't help but think, yes, but he never put his eye to the eyepiece that night on his own telescope, not once. The other thing, of course, this kind of astrophotography where the results are absolutely stunning. And I bow and worship those folks that have the mad skills to do that. That's absolutely amazing. But the entry ticket to get started in that kind of astrophotography, it's quite pricey compared to your basic 6 or 8 inch Dob or your 80 or 100 millimeter refractor on an all-test mount. It's many times the price. The other thing, apart from cost and accessibility, the other thing we look at with sketching is a very intimate act. It's you, the eyepiece, the planet, and it requires patience, it requires focus, it requires concentration and dedication. So does the astrophotography, but essentially you have robotic helpers concentrating and focusing for you. Mm-hmm. Here it's up to you as an individual observer. There's a connection with the great observers of our past who work this way. And really, I think when we take the time to look, if you're going to sketch something like Saturn, you start to realize really, seeing changes. Sometimes the sky is turbulent, and then you're peering through an atmospheric cell, everything snaps to and becomes stunningly crisp and beautiful. And then a few minutes later, it's wavering and flickering again. So this on again, off again. Did I see that detail? Let me watch. Let me see it clear. It's like the cat waiting at the mouse hole. Bam, gotcha. And we see these lovely details pop out. We record them. There's a great tendency amongst my students. And I had my first lab night last Friday. And my students came out, and not many of them were looking very forward to it. But as the evening went on, they realized we're having a lot of fun. I'm starting to see constellations now. And one young woman said today in class, she said, I came out and I was just looking out and it looked like somebody had taken a brush and flicked paint on a wall. It was just this random stuff. And then you started to take the laser and you were pointing out, here's the Northern Cross, this is Cygnus, there's the wings. This is Aquila, and it's supposed to be an eagle, and I kind of see that, and this, that, and the other. She said, after a few minutes, I started seeing the patterns. And she said, something happened, it changed. It's no longer a black sheet speckled with flecks of white paint. She said, now it's a series of patterns, and I could see where one stopped and the other started. This kind of personal, intimate relationship with the sky is something that we don't get when we use cameras and computers to take photographs for us. And when we keep these sketches in a journal, over time, we get to see our improvement. Not only do we get to see our improvement in this data gathering skill, I'm not going to call it art, it's not, it's data. We get to see our improvement as astronomers with this data gathering skill, and we get to record unique events. One of the things we saw Friday night, we had 127 millimeter Explore refractor out. We're looking at Saturn at about 75 power and enough to clearly see the rings. And my students were saying, well, what are those stars around it? I said, are you sure they're stars? Somebody said, could they be moons? I said, well, let's draw them and find out. And the immediate brilliant question came, how do we tell from a drawing? I said, well, it's not just a drawing. Your drawing is data. You can confirm your hypothesis by spooling up planetarium software like Stellarium, like Starry Night. You can set it for your location, the time of night. You can zoom in on Saturn, and sure enough, we captured Titan and Iapetus. And the girls were like, really? I'm like, yes, you did. You spotted them. Good job. This is the kind of thing that this personal sense of accomplishment. And certainly there are a lot of people who says, look at the photography, the photograph I took. But photography today very much is point your camera, push the button, and the computer inside the camera makes an awful lot of decisions about exposure, ISO, all kinds of things.
True.
Sensitivity of the sensor and the duration of the exposure, all these, for the most part, very, very few photographers put their cameras on manual today and adjust all those things artistically. They set it on automatic or time exposure, whatever. They point, they click, and then they process a little with some image processing software. But when I have a picture of Saturn that I've done, and I'll go ahead and share this one with everybody, and I'll share the screen. And come on, there we go. So I'm sharing this screen. This is a sketch of Saturn that's in my logbook. And I have the logbook with the little dots there. It helps me draw. And yes, I took a compass and drew Saturn. And you'll see there's some other artifacts on the drawing there that I didn't erase. I did that deliberately. But yeah, okay. I got the Cassini gap very nicely. It's out at the elbows of the rings there. It disappears as you move in towards the planet because the glare got bright enough that I couldn't discern it anymore. What's really nice is, and see if I can, there we go. We see the darkening here. That's underneath the ring. And my first thought was, oh, shadow of the ring on Saturn, but the angle is wrong. I realized later what I've captured the C ring. And it's visible as a darkening of the planet adjacent to the ring. And part of the way I knew that was comparing the width here versus the width here. And you go back and you look, how wide is the AB complex? How wide is the C ring? Where should it be? What's the tilt angle? What would the apparent width be? You do some math and you're like, holy cow, that's the C ring. One of the few times I've ever captured it. And I got some nice polar darkening and cloud bands and other things here. So overall, a successful sketch. How long did I take to do this? Less than 10 minutes. And I added some other detail from memory later, but the basic sketch was about a 10-minute sketch. And we can do this easily enough. We can do this easily enough. So when we think about this and we think about exploring the rings from Earth, the way our ancestors did, paleo, not quite, but telescopic astronomy between 1609 and really about 1910 is when planetary photography gets perfected. Actually, if you look at amateur astrophotography, that doesn't really come into play until late 70s, early 80s, almost not at all. When I was selling telescopes and you were hawking them as well, Scott, back in the 90s, we had a bulletin board at Scope City. And for photographs, people.
Oh, I remember.
There weren't very many because at that time we were still in an age of film.
Yeah.
Most of the time, the film was not sensitive in the right areas. So we would hyper the film. We would expose the film to a gas in the dark so that the gas would hypersensitize the emulsion and then carefully load the camera in the dark. And then we were making exposures and we didn't have the luxury of digital exposures. We couldn't take 1,000 photographs and pick the best 10 and stack them. we were doing one-shot images. And
Right.
yes, we had to track. Sometimes people wanted to track for an hour or more and keep the camera open for an hour. And today you couldn't do that. The satellites would ruin the photographs. And we use stacking technology and frame rejection to get satellite artifacts out of our pictures. It wasn't a problem then. But if you wanted the bright, beautiful image of the Orion Nebula or the Andromeda Galaxy or anything like that, the Hercules star cluster, which is much brighter magnitude, but it's a much smaller object. And so you think about when you magnify, you reduce the amount of light that's falling on the sensor. So you need a longer exposure. And so most people weren't equipped to do this, even in the 80s. So the era of amateur astrophotography with the digital sensor and the image stacking it's really a 21st century technology. It really is.
Yep.
And within the lifetime of probably most of our viewers, astronomers who were alive and observing 20 years ago were not really doing this. I'm going to put a webcam on a telescope and I'm going to take all these images and I'm going to stack them and the computer's going to align them for me. Things like Registacks and all that wasn't there. And so sketching isn't such an old-timey art as all that. But it's something that a lot of people feel hesitant about. But exploring the rings is an old game. Of course, we know about Galileo, and he viewed Saturn as kind of like a mug with two handles, and some people describe them as ears. I don't know that Galileo ever described them that way. But he looked at the eastern and western limb of the planet, and he saw two separate features. He was not, and his telescope didn't have the resolution to see the ring entire. It was considerably later, about a half a century later, 1665, Christian Huygens, and he's using a reflector. He got the design from Newton, and he scaled it up, and he made this lovely 6-inch reflector. And the mounting system was kind of crazy. It was only designed it was kind of like one of Tycho's instruments. It pointed in one direction, and it could be changed in altitude with kind of a chain drive elevator system. And so he would have assistants manipulate it. It was not a nice mount. And he would manipulate this, and then he would sketch at the eyepiece. And he was the first one to see that the rings were an entire structure circling Saturn, which was a great day. Cassini, just 10 years later, Cassini's using, I think, it was an 8.5-inch refractor.
Is that right?
One of the largest. Go ahead and Google that up. I think that's right.
Well.
But he's using one of the largest refractors in the world at that time. And he's discovering minor moons. He finds, I believe that Titan was already known, but he finds Iapetus, Rhea, Tethys, Dione, and the gap in the rings of Saturn that bear his name. And we know today the Cassini gap is caused by the moon Mimas, which interestingly enough is the smallest spherical moon in the solar system. It's only about 200 kilometers wide. It shouldn't be big enough to be round. Something makes me wonder if little impacts from inside the rings have polished it round. I don't know that. That's pure speculation, but it's kind of interesting to think about. And so Cassini is viewing all these things, and he's looking at Iapetus, and he's realizing, oh, you know what? I can see Iapetus. I can see this thing. This thing appears to be a moon, and it's on the east side, and I see it very easily on the east side, and I know pretty much the orbital period. And I'm seeing this go, but on the west side, I can't see it. And it's a number of years later. It's almost 10 years later. And he's now got an even better instrument. And he's able to track Iapetus on both sides of Saturn. And he thinks about it, and he makes a speculation. And he says, you know what? I think this thing is locked, gravitationally locked to Saturn so that it doesn't rotate independently on its axis, so that as it sweeps around in orbit, basically there's a front windshield and there's a rear windscreen, right? And so he said, I bet what's actually happening is that little things are smacking it on the one side all the time, making it darker, and the other side is lighter. And so he hypothesizes something that has never been seen before. He said, here's a moon that's gravitationally locked. That's our term for it, not his. Gravitationally locked to its parent body, to Saturn. And the two hemispheres are different because one hemisphere is always facing forward as it revolves around Saturn, and the other face is a different reflective character, a different albedo, because it's always facing rearward, if you will. Mm-hmm. And if you think to yourself, oh, if I go out and drive around, how many bugs do I get on my front windscreen versus my rear windshield, right? And your rear window, how many bugs do you get there? Not very many. You don't have to go and scrape it off all the time. But the front windscreen, you get lots of bugs on the front of your vehicle. And Cassini basically puts this hypothesis out there, and he sticks to it. I will die on that hill. His entire career, he claims this is true. It is not proven true until the Voyager spacecraft, and they didn't get to Saturn until, I think, around 1980. And they photograph Iapetus, and while one hemisphere is different than the other, and of course, the Cassini mission later verifies this, and they named the dark area on Iapetus Cassini Regio. Well, think about Cassini and think about Percival Lowell. Cassini had an idea, Lowell had an idea. They both had an idea that they stuck to based on very thin observational evidence. I think you could easily argue that Lowell's observational evidence of linear structures on Mars was much greater, based on a lot more observations of a planet that was a lot closer and an image that was a lot greater apparent diameter in the sky than Cassini's view of Iapetus, which could never be anything more than a pinpoint object in his telescope. He's simply noticing brightness. They both have a claim, they both have an idea, they both stick to it until literally their dying day. And Lowell is proved wrong, Cassini is proved right. Science, Scott, Lowell gets a raw deal. Oh, well, he just saw what he thinks he saw, and he was wrong, so ha-ha for him. Hubble predicted the expansion. He said, I have data, and he published his theory of the expansion of the whole bloody universe based on observations of 23 galaxies, all of which were nearby. Out of what, 500 billion estimated galaxies, the Hubble Deep Field photograph? Oh, there's about 500 billion of them there. And he didn't see galaxies that were outside of really the local group. And Hubble makes this grand claim on very thin ice, very slim evidence. Hubble was right, Hubble's revered. Percival Lowell was wrong, and we tend to have this idea that Lowell was a lousy astronomer, Lowell was a bad scientist, Lowell was this nutty kook. Well, who's kookier? The person who said there might be intelligently created surface structures on a nearby planet, or someone says the whole damn universe is expanding? An idea that even Einstein rejected. Who's going farther out on the academic limb?
Right.
And so science is very often people, very brilliant people. Vera Rubin in Dark Matter. Very brilliant people coming up with an idea based on very few observations and very thin evidence and throwing it out there. And science, Scott, is not, it's interesting. I was talking to teachers and they tend to want to, especially teachers of younger, science is this wonderful thing where everyone works together, and together, arm in arm, we march forward in progress and discover new things about the universe. It's not like that.
It's
Karl
it's
Popper,
a sausage factory. Is what it is.
it's a cage match. Karl Popper said science is
It
essentially
is.
destructive communal activity where everyone tries to make their reputation by destroying the other fellow's ideas. And the ones that go in the textbook eventually are basically last man standing in the cage match. The idea that no one is able to defeat. And it's only a long time, says Popper, after people fail again and again and again at destroying their idea, that people toggle over and start looking for evidence to support the idea. Einstein in Relativity is a very good example. He was ignored basically from 1905 to 1919. Eddington came and a lot of people were like, phooey. Eddington came along, went to the eclipse in Africa, brought back photographic data and said, wow, it works. Gravity bends starlight. And it's exactly as Herr Professor Einstein predicted. Wow, Einstein becomes famous overnight, but still, this is 1919. For the next 35, 40 years, a lot more people spend time and energy trying to knock down the theory of relativity. We heard, what was one of the most recent ones? The people at CERN said, oh, look, we found this thing with satellite data which says maybe relativity isn't right. It turned out they made an error and they came out, nope, we made an error, Al wins again. But you hear relatively frequently in the news still, oh, another successful test for the theory of relativity, which basically says not that people out there are trying to prove Einstein right. People are out there trying to notch their gun belt to prove him wrong. And Einstein, I've mentioned this on the program before, Scott, Einstein is really famous because he's the first guy in 350 years to make any significant correction whatsoever to Newton.
Right.
And so it's just kind of interesting. So when we go back to sketching, we come on back and we get to look at something that's an activity that really engages us emotionally in a way that cameras can't. I can tell you, I had 15 students out. We got a group of 42 in astronomy for educators this semester. 15 of the students came out last Friday for their first lab night. And I asked them, have you ever looked through a telescope before? And a couple of them went, me, and I set the 127 refractor up on its mount. And they said, now, how many of you looked through a telescope, a real telescope? Oh, not like that. Okay. And we got out a pair of 15 by 70 binoculars. How many people have looked through binoculars? Oh, not like that. And so I said, we're going to look at those later. Oh, so we spent the first few minutes. Oh, look, Venus, Saturn, Jupiter, and we traced the ecliptic for them across the southern sky. It's a curve? Why? I said, well, the plane of the solar system, and we're looking at it, it's like a round thing, and we're looking at it on edge. Oh, like a plate. Yes, like a plate. Wow. Okay. Let's look at some constellations. Let's look at the summer triangle. Let's look at Scorpio and Sagittarius along the south. And try to draw the summer triangle. Start by drawing the triangle. And I said, focus on getting the angles and the distances right. Draw a good triangle. Then I took the laser and I said, oh, this is Deneb, and this is Cygnus, and here's Altair, and here's Aquila, and this is Vega. And as it gets darker, you can see Lyra. Like, wow. And they're all drawing. I said, now let's go look at Jupiter. What do you see? Wow, are those moons? And the emotion, the raw emotion that's there. One girl looked at Saturn and she cried. She said, oh my gosh, this is so beautiful. She said, I've never seen this. It has an emotional impact. And I'm sure all of those students have seen photographs of Saturn and Jupiter at one time or another, in a classroom, if nothing else. But it doesn't have the punch in the gut, slap in the face with a wet mackerel impact that seeing that planet in the eyepiece on your own.
Live.
I'm like, yeah, that
Right.
that light started out from Jupiter 3 hours ago, and Saturn started out 6 hours ago. Ah! So it has a wonderful visceral impact. So let's do some sketching. I don't have my two cameras split here, so it's going to be earthquake. Here we go. I'm going to switch my camera.
There we go.
And there we go. So when we start sketching, there we go. I'm centered now. Good. When I ask people to draw Saturn, and I noticed this for years, what I would get, and I said, okay, you're looking at Saturn, go ahead and draw it. And I would get this.
Nice.
Okay. And you go, yeah, okay.
Not a lot of detail on the rings, but you know.
Not a lot of detail on the rings. And I said, is that all you see? Well, yeah. I said, oh, can you see the rings are a little wider than that? Okay. And, you know, and they very carefully do this. And I said, it looks kind of like a, you know, brickyard oval in Indy there. Well, that's what it looks like. I said, is that the right size compared to the planet? Well, sure. And even when I said, tried this in class, I said, okay, let's take a Hubble image of Saturn, okay, and throw it up on the screen or from a textbook. And I said, try to draw this. I would get the same kind of cartoon Saturn result. People have a hard time visually estimating how wide the rings are, how much they are inclined toward us, and they have trouble scaling the idea from width to height compared to the disk. And so people were having all this difficulty. So I developed a new method. And of course, my marker bled through here. So take a couple sheets away. I developed a new method, Scott, and
Okay.
this has evolved over the years. But basically what I said is, okay, we're going to do what's called a box and rectangle. So I said, everybody take a ruler, draw a box. And what we're going to do now, this represents, of course, what goes in the box. It's the disk of Saturn. And basically, I would have them look in the eyepiece. And the next thing I said was, all right, look in the eyepiece and tell me how close to the edge of Saturn the rings get. Do they get all the way to the edge of the planet? Do they project beyond the edge of the planet? And I said, draw me a line. And so they would go ahead and say, all right, well, it comes top and bottom. And they would say, oh, should it be the same? I said, yeah, it should be the same, top and bottom. They said, okay. And now I said, how wide is it? And they said, well, how do we know? I said, well, take a look at the size of the disk and think 1 banana, 2 banana, and tell me how much farther out. And they go, wow, it's pretty far. It's like almost 2 diameters out. It's not quite 2 diameters, about 3 radii. It's about a diameter and a half. So I would say, okay, extend that box out. And you think it's about 2.5, a little more diameters out. And I said, okay, guess what's going to happen now? We're now going to draw the rings are going to be drawn in here. And so we go, oh, we need a big ellipse. And it's going to look like this. Mm-hmm. And it's going to come on both sides. And I said, now, where's the inner ring go to? Oh, well, it's pretty close. It's in about here. And I said, okay, draw your second ellipse. And it comes like this. And the other end goes like so. And I said, all right, now put your disk of the planet in there. And now with what I call the box, and rectangle. With the box and rectangle method, we were able to come up with a relatively good sketch of Saturn. We would go, oh yeah, well, this is all dark in here. So that's the inner part of the rings. Shade here, shade here. And it starts to look not too bad. Starts to look not too bad. What I evolved this into, Scott, was a diagram, and I'm hoping I'm going to put this as close as possible so it's big so people can see it.
Yeah, we can see that.
Okay. So this is a diagram, and this diagram is in the episode guide for today. And I actually, apart from the episode guide, I also went ahead at the bottom. There's a page with 2 of these diagrams on it that our viewers can print out, as many as they like. And then they've got 2 diagrams per page, because sometimes you get started drawing and you go, oh, darn it. And at this point, Scott, you'll notice something. And yes, I cheated. I drew this with a compass.
Nice.
So
Yeah.
I drew my circle with a compass. And for those of you who are wondering, this diameter of Saturn is, I think it's 1.5 inches. I didn't do it in metric. No, it's a 2-inch circle. So it's roughly, what, a 5-centimeter circle?
Right.
That's what this is on construction paper. And the entire diagram is about 20 centimeters wide. And you'll notice I basically used the radius of Saturn as a unit of measure. So we've got 1 radii. 1 radii is to the edge of the planet, of course. 2 radii is out to here. 3 radii. This is out to about 4 radii. So 1, 2, 3, 4. And then going up and down, I've got in half radii. So 1/2, 1, 1.5. And they're marked positive and negative on the axis of the graph. Well, if we look, we've got some lighter lines on here. This line here at 3.5 radii, and it's right here, and it's at plus 3.5 radii. That line right there represents the outer limit of the A ring. And of course, we've got the negative 3.5 here, which represents the eastern and western limbs.
Okay.
And we've got this inner line, and you notice there are 2. The reason there are 2, the inner one is where the C ring goes at about 1.5 radii from the center of Saturn out. That's where the C ring extends to, but the AB ring complex, the B ring, starts about here at 1.75. So we look at this, Scott, and we decide, gee, what's the height of our box? Well, right now, when we look, it's really kind of nice because the rings right now are just about reaching not quite the edge of the planet. The maximum tilt is about 29 degrees, and at that point, the rings will get a little above and below the edge of the disk. But right now, they're not that far. The rings are closing down right now. 2017 was the last full open appearance of the rings. And this goes in 7.5-year cycles from fully open to edge on. And so our next edge on event is going to be 2025. So we're about midway. So we can go ahead and we can put some spots on here, and we can say, oh, I see the ring is at about not quite 0.75 radii. And I'm going to draw my inner boundary. So I'm going to draw my inner boundary to here, because that's the B ring. That's the one I can see. And one edge is going to come across here. And yes, I'm going to come all the way out. And then I'm going to come back, and I'm heading for this line. And I'm coming back, and I'm going to stop at the edge of the planet. The B ring comes from here, and it's coming all the way up almost to the top of the planet. And it comes all the way down to about here. And we can sketch the other side just the same. I'm going to mark my points so I get it right. And I get all the way out to about here. And then back in. And again, I'm getting all the way out. To about here. My inner space. Now, I'm doing this A, freehand, B, sideways. And these aren't the best ellipses that I can draw, but what I get is a clear image of the planet. And the planet is clearly cutting off the part of the ring that lies behind. And the ring clearly cuts off the other part that lies in front. Now, if you have a drawing tool called a French curve, are you familiar, Scott? Do you ever remember?
The French curve? Oh, yeah, it had like the little...
It has a weird curly Q sort of a thing. A French curve can help you draw a very nice ellipse because you know that you're going to be absolutely perpendicular here and here, right? So you can set up the French curve and draw a very nice, beautiful ellipse. But the other thing to remember is that our polar axis for Saturn runs right through the middle. So if the rings are tilted this way, we're basically going to see bands on Saturn which are stretching across this way, right? And we can clearly see, oh, this pole is tilted towards us, this pole is tilted away. Do we notice that we've got the C ring? We might see some very faint blurring in here on the planet's surface, as I was able to the other night. And that says, bingo, well, maybe you've captured the C ring. Now, the interesting thing about this, you can see, oh, if I've got the Cassini gap, where does it appear? Out at the elbows. Oh, well, it appears here. How far back can you trace it? Well, I can trace it to, you know, however far back I can get. And it depends on your seeing conditions and it depends on everything else. And I was able to get the Cassini gap about like so. I was not able to pick up the Encke gap. I have before in a telescope, but not the other night. I got the C ring, which was very nice. The Encke gap requires really exceptionally stable seeing. I've done that out in the low desert after a storm, and the sky was just pristine, dust-free, cold front, cells sitting there, so the air was very still. And I've been able to get the Encke gap. I've been able occasionally to get radial structure out on the elbows of the rings.
Yes.
Was not the other night when I did the sketch that I'm talking about here. But the interesting thing, and I think I've got the original sketches in here somewhere. There's the original sketch. And so
Nice. Yeah.
it's when you do it right and you get the size and proportion, you go, oh yeah, that's Saturn. People take a look at this and they immediately recognize, oh yeah, that's Saturn. Now forgive me because my exact proportions here aren't correct, but the drawing template on the episode guide is correct. And it's based on sizes of the rings as measured by NASA and ESA and the Cassini probe and other things. And you can basically say, how wide is the A ring? The A ring goes from here to here. And you can go, okay, well, let's convert that into radii of Saturn. It makes it very easy to draw a very precise drawing guide. And you get something that really, it looks good. And
it looks good.
Scientifically
it's an accurate technical drawing, you know.
Exactly.
Right. One of my favorite, probably not only my favorite, but many people is Truvolo made a series of astronomical drawings in the 1870s.
Oh, yes.
And I know you've seen this. I'll just share it real quick. But this is Trouvelot's drawing of Saturn in 1874. And it is spectacular.
That's stunning.
You can see much. I mean, you can see those inner rings there. You can see Cassini's division, Encke's division. You can see some of the shadowing across the plane of the rings themselves,
Stunning.
and also the features that you were showing.
Yes.
Across the bottom there. So there's just some of his drawings are a little stylized, but this one, wow! The first time I saw it, I mean, almost like photographic. It was super good.
It's a stunning sketch.
Yes.
Well, now, was that colored pencil, or was that, do we know?
What's that?
Was that done, Trouvelot, was that done with colored pencil?
I don't know.
Because it looks like it has
They actually
color.
had
shades
his
of color
drawings
in it.
on display. They had his drawings on display at the Crystal Bridges Museum here in Arkansas. They were huge. I mean, just incredible. So it's quite a treat for me to go and see
My
them.
drawings will never be exhibited that way.
Yeah. But very nice drawing for, capturing the observation that you made. So I think it's very
Indeed.
cool.
Indeed. So we've got this. There we go. I am back. So we have these lovely drawings. And when we were out the other night, and we captured two things, and I think I can show them here. We captured one moon, was off the other way, below the planet, and the other was up and farther out to the right, quite a number of diameters. And yeah, those were Titan and Iapetus, and it's lovely to get in there and record them. What we're going to do next week, Scott, is we're going to take a look at how do you record the moons of Saturn. The moons of Saturn represent a much bigger challenge than the moons of Jupiter. The moons of Jupiter, Jupiter's inclination for its axis is virtually zero. And although it varies 5 or 6 degrees either way, the moons, the Galilean moons, they're very big, they're very bright, they're brighter than almost any star. Jupiter goes past. So it's immediately obvious, aha, it's a moon. And we can see them, and they're right in line with the equatorial bands. And so it's very easy to identify them. Saturn's moons represent a much greater challenge. Titan is usually easy to get because it's quite large. It's bigger than Mercury. But Saturn inclines as much as 29.5 degrees. So when we think about the orbits of the moons, they're not little ellipses tilting like this. They're going 30, they're rolling like a ship on a choppy sea. They roll 30 degrees up. And so you can see them above the planet, below the planet. Iapetus on top of that has a 17-degree tilt with respect to Saturn, and a gigantic, enormous orbital radius. And so Iapetus can be all over the place. Then you get into the minor moons. The minor moons never get very far away at all. They're always right in and around Saturn. And they're challenging because we're plucking them out of the glare of the rings.
Right.
So we're going to talk next week about how to hunt and capture the moons of Saturn and how to identify them. And I hope there'll be another episode guide, of course, I developed a brand new set of diagrams to help people catalog and identify moons of Saturn. And it's really quite interesting. I developed another interesting technique, and we'll reveal that next week. But with a diagram like this at the eyepiece, it's very easy to accurately diagram. And then, of course, if you can accurately diagram, you can accurately identify. And really kind of fun. And I hope we're kind of putting the fun, the adventure, the exploration back into astronomy for people.
Oh, sure.
Take nothing away from our great astrophotographers, and you've had many on the Global Star Party and various programs, and I admire the heck out of those folks. At the same time, I know they are really working with a level of expertise and a quality of equipment that an awful lot of amateurs just can't reach. And we shouldn't despair. We shouldn't despair. We should have confidence that we too can capture the planets and capture the moons and document them in beautiful, elegant ways.
Yeah, and an intimate way too, because you're drawing it. You're laying down the lines based off of what you saw. And I would say that it is, if you've ever drawn a portrait from life, depending on what your skill level might be like, still even so, even if it comes out horribly distorted and you look at it and would not show this to anyone, or you're doing your picture of your mom and she screams after she sees it, still it is you laid down every line, every part of her. And it's the same thing when you're doing astronomical objects. The good thing is that they don't scream back. So, that's really
much easier to draw than your mom.
Much easier to draw.
A couple ellipses, a little bit of shadow, and a couple of
That's right. And by the way, Trouvelot did those drawings. He did 7,000 astronomical drawings. He was an illustrator, professional illustrator.
Yeah.
He did them in pastel. But they're stunning. They are.
Wow.
I'm sure by the time he wasn't an astronomer. He was not really. I mean, he had his interest in it, but I think that his real hobby was as a entomologist, I guess, and he was
so he was drawing
responsible
bugs
for introducing the invasive species, the gypsy moth, into the United States. So very talented at the eyepiece. I think he should have spent more time there, but okay.
Yeah, I guess so.
Couldn't leave nature alone. So
well, that's all right. Anyway, I hope everybody will come back next week, and I would love, Scott, if some of our viewers would send in their sketches. If they emailed them in, I would love to see some. Anybody have fun questions today before we wrap up and
let's look at who was on with us today. We had, of course, Richard Grace. Martin Eastburn says, howdy, I'll hope the storm missed all of us. Cameron Gillis is watching. Mike Wiesner from cloudy Arizona. He said they had a great lightning show last night, which is cool. Book Davies is watching. Harold Locke says Mighty Monday. I like that. I always put down Happy Monday, but Mighty Monday's better. Pekka Hautala, hello everybody, and great day to start this week. Thank you. Let's see. Martin Eastburn is mentioning his Dr. Clemens, I guess his department head in physics would start a lecture on the board at 7 a.m. class and then fall asleep in the process. Slowing down, sit down, and out. Someone moves chair and back to the board. So
I never did that one.
You never did that.
I never did that.
Maybe he was a bit older than you. I don't know.
Maybe.
Yeah. Cesar Brolo is watching down in Argentina. We've got Jeff Wise watching. Norm Hughes, often with us as well. Almost all of these people are regulars here. Chris Larson. We have, might have mentioned Harold Locke.
Yeah.
And Book Davies comments, he says, Lowell might have been wrong, but he was a fantastic science fiction writer. Without Lowell, no War of the Worlds, no Barsoom. Besides somebody has to be wrong sometimes. So be wrong big. Okay. Yeah.
I
Well,
try to
it'll
tell
be
my students
interesting if
that
they find life on Mars. We can't say that he was wrong big. Okay, maybe not. Bipedal aliens. With
and build
giant
a
eyes,
woman,
but
gets a statue. I'll build it myself out of Lego.
that's
He gets a
right.
statue, man.
That's right. They should put a statue to Lowell up on Mars. I think that would be cool.
Yes, indeed.
Let's see. Any other? Oh, Book Davy says it takes a little practice to develop a sense of proportion in
It
sketching.
does.
Yes, it does. But
Yes, it does.
yeah.
And please don't throw your first efforts out. Even if you don't show them to others, your own documentation of self-progress is valuable. Really, it is. And I have trouble convincing my students of that. Can I throw it away now? I hand them back their sketches after I grade them. Can I throw it away now? No.
No, you got to keep
don't
it.
do that.
Yeah, that's right.
And, please remember something I tell my students all the time. We don't do science to prove we are right. We do science to become more right. And it's a process. And we celebrate the progress and the achievement. And you can't ever celebrate achievement if you don't know the starting point. So save those drawings. Save those drawings. Document the starting point.
Yeah, and share them with us if you will.
I would hope. Please.
Yeah, and one other person we haven't seen in a while is Wolfgang, who was a regular early on in our programming, but he's back, telling us he's
Glad
alive
to see
and
you back.
kicking. So that's good. And Book Davies wants to know, how do you make a decent black background?
If he's talking about the sketch that I had, that was just pencil. That was just pencil and
Well,
paper.
you could start off with black paper and do
You could.
pastels or something.
I've tried that. I've tried sketching with silver and white pencils on black paper. I've never, and I know people do scratch board. They take a white background, they paint black over it, and then they scratch the paint away.
Okay.
I've never been able to do that either. And so essentially, to answer Book, I basically draw a negative image where it's my sketch of Saturn, I guess, is a positive. Try to find it here. My sketch of Saturn, I guess, is positive, and you see the but that's just pencil sketch in a notebook.
Right.
And I don't really worry about the black background.
Yeah,
really
you do
don't.
the inside black. So
I did inside the rings
yeah.
to kind of show the separation. And in person, the way the pencil strokes are and everything, it gives it a much more three-dimensional feel. I don't know if that's coming across on my little camera with the lighting I have in my studio or not, but and the image that I have that I shared of my sketch, it doesn't come across that way, but it has a three-dimensional feel in person, and I enjoy it. I mean, I'm no Troubadour, that's for darn sure, but
well,
and I'm not an artist, friends. I'm really not an artist. If I drew a picture of self-portrait of myself or Scott, you would have trouble recognizing them for life portraiture at all. And I am not an artist. I'm relatively decent at technical drawings, but draw a rose, a flower, a bug, a person, not so much. I try to tell my students
techniques on drawing a flower like you do on Saturn. You would.
I'm sure. Tell my students for sketching constellations that, come on, it's a dot in a straight line. This can't be hard. They call me a liar, but yeah, it is.
Liar. That's right.
Take a new piece of paper and try again. And I've had people give me back labs and say, how can you give me full credit for this? Well, were you there? Yes. Did you try? Yes. Is that your best drawing of the Big Dipper that night? Well, yeah, I did it 3 times, and this is the least worst one. That's an A. It's about data, not art.
That's
and
right.
I do get some students with artistic skills who turn in some just stunning
Cool.
work.
Yeah.
And it's weird because some of this stuff is done on lined notebook paper. I'm like, no, this should be on art paper somewhere. But most of us don't do that, but almost all of us can document what we see at the eyepiece relatively well. And we're going to have a couple shows. I think we're going to have a second and a third show. The second one's going to be moons of Saturn. And then I think we'll have a third one on sketching something that I refer to as the clock method. And I developed that one for sketching lunar features.
Well, that's cool.
Loads of fun.
There's not very many places you can go to learn how to draw astronomical objects. So this is a great series.
Yeah, I don't know of any offhand.
Yeah.
I've never seen, every once in a while you see something on the internet for an art course. Remember when we were young, Scott, and used to be in the back of the comic book? Can you draw this puppy? Send it in.
Oh, right.
Get a free evaluation for an art course.
Sure.
And essentially, yes. At my own college, a woman was applying for an art program, and they asked her to send in 2 drawings. And this is true because I saw this, and they were about to send it back. And somebody said, wait a minute, that's not a stamp on the envelope, it's a drawing.
Right.
And indeed it was, and the post office canceled it and mailed her letter. And they admitted her to the program.
So let's see. In the download link for this episode, or for Sketching Saturn, do you have like a sketching?
Yeah. If you scroll all the way to the bottom, the very last page, and I guess it is page 6 of 7 on the curriculum guide, there are basically 2. It's a page you can print out, and it gives you 2 of these sketching templates, and gives you a place to record name, date, and time on one line, location, scope, and magnification on the other.
Right.
And so the viewers can print these out and take them to the eyepiece. Absolutely.
Right. So the way that you get the guide is it's free of charge. You go to, let me give you the exact link to go to.
Okay.
And you have to pretend you're buying it. Okay. Because it wants you to add it to your cart,
but you put it in your cart anyway.
For free, you get to download the PDF guide. So that's how it works.
There you go. And of course, anyone who has questions is welcome to email me as usual at astronomyforeducators@gmail.com. And if I don't know the answer, Scott, I'll make up a fascinating science fiction answer just for them, just for our viewers.
Why not?
That's right.
That's right.
And I won't tell a lie. It will be clear as you read it that it's actually sci-fi. So
okay.
But I always used to use that in my class.
You do sci-fi.
What if you don't? What if we ask you something you don't know? I said, I'll make it up, and then it's your job to tell if it's fake or not.
Right.
None of my students ever liked that answer, except that when they came back years later, they said, no, that was really funny. But at the time, not funny. You're supposed to tell us the answer. Anyway, we'll see everybody next week, Scott. So glad to have our viewers.
Thank you very much, Daniel. Thank you very much. And tomorrow, of course, we have the Global Star Party. It is our 60th Global Star Party, and the theme is the local group, which pertains to our local group of galaxies. So you can imagine where the talks might lead, which could actually connect anywhere in the universe. So we're looking forward to having you join us for Global Star Party tomorrow.
We have a guest appearance by the Great Attractor.
Yeah, that's right.
that was a joke from Men in Black, right? That was the Great Attractor sent.
The Great Attractor. That's right.
Yes. So there we go.
Mm-hmm. We have some other great star parties in the works. September 14th, I believe, is John Dobson's birthday, and that lands on Global Star Party night. So we are talking to the people from the Sidewalk Astronomers, to people who knew John Dobson, and so we're hoping to put that all together. So far, they're all saying tentatively yes. Okay, so that'll be very cool. And then on September 25th, we'll have a Saturday Global Star Party with the Royal Astronomical Society of Canada, the Montreal Center, and they are planning to do something in conjunction with an astronomy club down in New Zealand. So this should be pretty cool. Yeah. So it's a lot of fun. And so we've got lots of stuff in store for you. Hope you enjoyed last week with Tom and Linda Spilker, who talked about Saturn and talked about Voyager and all of that, and space stations. The Tom Spilker's work on a rotating giant space station, which is supposed to be built in 10 years with robots, and astronauts telling the robots what to do. But anyhow, it's been a lot of adventure so far, and we got more adventure planned. So until that time, you guys do what my friend Jack Horkheimer always used to do, and that is to keep looking up.
Absolutely.
And have a great night. Take care.
Bye-bye,
Thank you,
Scott.
Dan.
See you all next week.
Bye-bye.